All right, continuing from the last lecture, this is the second lecture on differentiation. Let me open with the examples here. I want to find the derivatives of these three functions, and I would like you to also, after I've done A and B, please try C. Okay, I assume you already, please make sure you watch the first lecture before you come to the second lecture, okay? Because the first lecture introduces you to calculus. I did a revision. I take you from what you understand, refresh your mind, what you did from high school, and also introduce you to a product and quotient rule. And then I listed the standard common derivatives. So please watch the first lecture. It's very important before you come to the second lecture, okay? So now I want to find the derivatives of these functions, okay? Let's start with A. I was giving my function as x to the power 5 times e to the x. As you can see here, I have a product of two functions, x to the power 5 times e to the x. So y is a product of two functions, and I want to find a derivative of y, and then y is a product of two functions, so I'm applying the product rule, okay? Just to remind you, the product rule, when you're deriving the product of two functions, the derivative of this product is a derivative of the first function, derivative of h, while you leave the second function, g of x, plus, and leave the first function and multiply by the second derivative of the second function, derivative of g of x. So here, let's apply the product rule. We treat this as h of x and this as g of x, the first function, and this is the second function. So the derivative of y, derivative of this product, is the derivative of the first function, derivative of x to the power 5 is 5x to the power 4, while we leave the second function, plus, and leave the first function and deriving the second function. You remember from last lecture, the derivative of e to the x is e to the x. Derivative of e to the x is e to the x, okay? So this is just a derivative of this function, okay? So the next step was just simplification. So I took e to the x as a common factor, right? So the first term, we left with 5x to the power 4, plus in the second term, we left with x to the power of 5. Okay, this is the derivative of this function, all right? This was the first example, okay? A. And let me do B. B, y is equal to x times ln x. So I'm going to find the derivative of this function. And then again, I say I have a product. So I'm going to apply a product rule, all right? P, this is the function P, all right? This is a function P. Y equal to x times ln x. So I'm applying the product rule. Please, from this example, I'll assume now that you understand the product rule. If you don't understand product rule, just pause this video and stop, and please go back to lecture 1, all right? So if you understand now product rule, continue with me, okay? So here I'm deriving the product of two functions. I understand now I'm deriving the product, so the derivative of this will be a derivative of the first function, derivative of x is 1, while I leave the second function, ln x, plus, and leave the first function, which is x, and multiply by the derivative of ln x. The derivative of ln x is 1 over x. Even right here, I gave you this as one of the common derivatives. When you're deriving ln x, the derivative of ln x is 1 over x. Or if you like, you can write in this notation. When y is equal to ln x, and derivative of this function y is 1 over x. It's just a matter of notation. You remember when I said when you see d over dx of a function, it means it's the same thing as dy over dx, okay? So this is a derivative, and the second step was just simplification. First term is ln of x plus 1 after x and x cancel, okay? That was just b here. This was just b, all right? And please try C as an exercise. Pause this video and copy C and try it as an exercise. And from lecture 1, I also give you the derivative of sine x. Just for simplicity, just know the derivative of sine x is cos x. But apply the product rule because we have a product rule here. And let me give you another example here. I want to find dy dx if I'm giving my function y as 2x plus 2x times cos x minus 2 sine x. I want to find the derivative of this function. So the derivative of the difference and sum of the function, it means we differentiate each term. So when we are differentiating the first function, the first term, we see the product. You see 2x times cos x. I said to you, when you deriving the product of functions, apply the product rule. Always, when you see the product of functions, whether it's a exponential multiplied by algebraic or only algebraic, so as long as it's a product, just apply the product rule when you're finding the derivative of the product, okay? So the derivative of the first term, I'm applying the product rule. Here, derivative of the first, I'm applying the product rule in the first term. Derivative of the first, derivative of 2x is 2, while I leave cos x, the second function, plus, and leave the first function, which is 2x, and deriving the second function, derivative of cos is minus sine x. So you see, the derivative of the first term is all this I put in a square bracket, it's a product rule, okay? And then minus and derivative of this, I return 2, and derivative of sine x, I don't have a product here, okay? So the derivative of sine is cos x. Okay. So the next step was simplification. I see cos 2x minus cos 2x is 0, and then I left it this time. It was minus 2 sine x, 2x sine x, okay? Okay, example 3. I want to find dy dx if I'm giving these three functions a, b, and c. So with these three examples, I want to illustrate the mistakes students that they're doing during the tests and exams, okay? So let's start with A. I'm going to find the derivative, but I want you to tell me if I'm wrong or correct, okay? So I'm deriving A. A is y equal to 3 ln x. So when I was deriving A, I see the product 3 times ln x. So what I did here, I just applied the product rule. Yeah? Derivative of the first, if I check 3, derivative of a constant is 0, while I leave the second ln x plus and leave the first 3 multiplied by the derivative of the second. It's 1 over x. So when I simplify this, I got this is 0 because it's multiplied by 0 and 3 over x. So the final answer is just 3 over x. Okay. My first question, is my answer correct? Yes, my answer is correct. But another question, did I have to apply the product rule here? Did I have to apply the product rule here? No. If you understand the product rule, we apply the product rule when you have the products of a function of x. You don't have a product of a function here. Yeah? We have a constant multiplied by the function. Yeah? So we didn't have to apply the product rule. So the simple way, when you don't have a product rule, you don't have to apply the product rule. If you don't have a product of two functions, you don't have to apply the product rule. So finding the derivative of this, I can simply go straight and deriving ln x without saying apply the product rule, and leave constant and just straight and deriving ln x. So I leave 3 and deriving ln x. The derivative of ln x was 1 over x. So the answer is 3 over x. Yes, the answer is correct here, but I didn't have to crack my head. Just know you apply the quotient rule when you have a product of two functions, because sometimes you can just go straight and find the answer if you have a constant times a function. When you have a constant multiplied by the function, go straight to that function and derive. Okay? This was straight away. I didn't have to crack my head and use a product rule. Use the product rule when you have a product of two functions. And then again, 3b, this is b, this is b. And then again, here, I see the product. Students, sometimes when they see the product, they always apply the product rule. So they apply the product in the first. This is a product rule here, deriving the function here. So they derive the first 3 pi to the power of 2 when they derive pi to the power of 3. And then they leave the second plus they leave pi and deriving x as 1. And then the question, is this correct? No, because this is a constant there. For treating this as if it's a function that you can derive, the derivative of this you are supposed to be 0. That's the first. And second, this is a constant. Pi to the power of 3 is a constant. It's multiplied by x. You don't have a product of a function of x, so you don't have to apply the product rule. So to find the derivative here, when you have a constant multiplied by the function, you just go straight to a function and derive it. So finding the derivative here, I was going to leave pi to the power of 3 and just deriving x. The derivative of x is 1. That's what we get here. So the final answer is pi to the power of 3. So when you have the products of a constant and a function, you don't have a product of a function. So you leave the constant clearly and then go straight and deriving the function. That's the first mistake students they do. They always apply product rule even along a fanele con. So don't apply a product rule in this case. Apply when you have a function, multiply by the function. And for C again was given this, and yeah, you're given this function. Again, you notice e to the 2, it's a constant. So you can leave the constant, e to the 2, and go straight and derive your function. X to the power of 5, the power rule, take 5 down, from 5 minus 1. So yeah. And then the next step was just simplification. I start with 5 e squared x to the power of 4. All right. Okay. Let me check time. Okay. All right. Let me give you another example. We're polishing a product rule last lecture, last examples. Now let me give you some example involving quotient rule. Okay. We want to find dy dx if we're given these two functions. The first one is sine x over x squared, and b, we have a function y equal to ln of x to the power of 3 over x. Okay, so we want to find the derivative of these functions. Let's start with a solution. dy dx. I'm deriving y is a function over a function. So again, always when we're deriving a function over a function, we apply the quotient rule. A quotient rule says derive the numerator. The derivative of the numerator is cos x, while we leave the denominator function. I assume now you understand quotient rule by now. And minus, and leave the numerator function and derive the denominator function. I check the formula that I gave you for a quotient rule and denominator function in squared. Okay, so again, let's repeat this. A quotient rule, a derivative of the numerator while we leave the denominator function, minus a numerator function multiplied by the derivative of the denominator function, and then you say all over a denominator function in squared. Okay, and then you can write the final answer. The final answer here is just okay, here you can take the common factor, which is x, okay, and then cancel one x, so you'll see the final answer is just x cos x minus 2 sine x over x to the power of 3. Why? Because here we have x to the power of 4. What I did from this term and also from this term, I took a common factor of x. After taking x out, that x that I took as a common factor, I divide with x to the power of 4. That's why we have x to the power of 3. Okay, so I took x as a common factor. That's why we have x here, cos x over. And here I took this as a common factor. It's the one that cancelled with x here. This is also O x to the power of 3. So we're gonna left with 2 sine of x. All right. Yeah, that's how I simplified my x. That was my first example A. And let's do b. Let me rewrite this b here, down here. This is b. b is y equal to ln x to the power of 3 over x, okay? Again, I have a function over a function here. So you know you have to apply the quotient rule, all right? And let me give you a tip here. We're still going to get into this section in detail. Whenever you have ln, you can start by applying the log before you differentiate. Log properties before you differentiate. All right? So I have ln of x to the power of 3. And then by log property, I can take this 3 down here. We have a section, the last section, which is log differentiation. We're going to apply the log properties before we differentiate complicated exercises. But in my advice for now, when you see a log property, apply the log, because we simply believe that it's easier to apply the log properties before you differentiate, okay? So now I'm finding a derivative of dy dx, derivative of this function. Y so far is 3 times this. When you have a constant multiplied by a function, you always leave the constant and constant and derive your function. So I noticed the function that I want to derive is a fraction. I'm going to apply the quotient rule in this function over a function, okay? So the derivative of this is the derivative of the numerator. Quotient rule, if you understand now, is derivative of the numerator is 1 over x, while we leave the denominator function. The denominator function is x, and say minus, and leave the numerator now, and multiply by the derivative of the denominator. Denominator function is 1 all over the denominator function in squared, so x squared, okay? So this is just a derivative, okay? So the derivative of a constant multiplied by a function, it's a product of a constant and a function. You didn't have to apply the product rule first, and then so you can go straight and derive this function. You notice it is a function over a function, and then for this function over a function, we apply a quotient rule. We leave the constant out and just deriving a function over a function. Quotient rule, derivative of the numerator is 1 over x, while we leave the denominator function x minus the numerator function times the derivative of the denominator function all over denominator function in squared. Remember, the derivative of ln x is 1 over x. So this is just a derivative, and next step, simplify. So always simplify when you do exercises or examples, okay? So this is 1 minus ln x over x squared, okay? Yeah. Okay. Let's go back to these two examples here. Let me give you a tip, okay? I didn't want to tell you equality because I wanted you to know a quotient rule. Sometimes you may need the quotient rule, okay? But I always try to avoid a quotient rule by convert everything to product rule. So here, I know I apply the quotient rule if I have a function of a function. So I always try to convert everything into I always convert everything into product rule. I prefer product rule. So I take my denominator. You see, now I have a production. I just took this to the numerator, right? Times sine x. And then this is still my y. I'm deriving y. Next thing, I'll apply the product rule when I'm finding the derivative. When you simplify, the answer will be the same. Okay. And also here, you can always convert this into product rule. Product of two function x to the minus 1. If you take this, multiply by lim of x to the power of 3. And then you can apply the log properties first before you differentiate this. All right. Okay. And the next section, we're going to use a formula sheet. I'll send you the formula sheet right now. But for today, I'm going to focus on the first formula on your formula sheet that I'll send you by now. My examples will be based on the first formula, but I will try to cover all those formulas in my examples, okay? So yeah. So the next section, we're going to use the standard formula sheet, okay? This section, I'll send you the formula sheet, and the alternate method in book, they use substitution. You're welcome to use, but I'll just want to choose one method. Use substitution. They usually don't give the formulas. Because I want to give you the formula sheet so your life will be easier, I'm just gonna go straight and use the formulas to evaluate the derivatives. Okay. The first standard derivative in your formula sheet is this one. Okay. It's this one. Let me write it here. The first one. When you derive anything that is in the form of a function that is to the power of n, the derivative should be, you take n, you start by take as if f of x is in the box that is to the power of n. You derive the box first, take n down, leave your function inside, and then from n you minus 1, okay? And then multiply by the inner function, the function that is inside there, the derivative of this function that is inside. Okay. This formula will be given to you if you need it. So my program will be based on this first, and then I'll try to go through as much example, I'm trying to cover all the formulas on the formula sheets. I think there are 13 formulas, okay? And these standard formula sheets or U substitution is based on what we call it a chain rule. A chain rule, okay? It's just a name given to those all standard formulas, okay? Why? Because we're deriving the box, we have inner functions. I'll show you the forms of all the inner function of a function. We have some function that is to the power of n. Inside that function, we have f of x. So we take the outer function as a box. So we derive the box multiplied by the derivative, the function that is inside the function. When you do that, you are applying the chain rule. So the first form is this formula, and this formula, for the simplicity, it will be given during the test. Always when you're deriving a function that is to the power of n, function that is to the power of n, you will come to this formula, right? Let's look at the examples applying this formula. Always the question would say find the derivative, okay? So here, I'm finding dy dx, derivative of this function. My function is x squared plus 2 all to the power of 3. Okay, what you notice here, you see we have a function that is to the power of n3. Yeah? The inner function, you see this quadratic, x squared plus 2 is to the power of 3. Always when you have this form, you can apply this formula. Okay. So because I always like to make your life easier, that's why I just say find dy dx. I'm not saying use which method, because I'm open to any technique that you're thinking that will help you to find the derivative. So another way of finding this derivative here, you see, if I like, I can open the brackets and just differentiate its sign. So you will come to that. But this formula is very helpful when n is to the power of 100. So you can't like multiply the times 100 times. So it's better to just use this formula, right? So you can confirm this with this example, apply this formula, and also start by opening the bracket, and you see the exam, the answers will be the same. Okay, so I'm giving y. If you check, my function is to the power of n. When you have a function that is to the power of n, the derivative of the function that is to the power of n, it's n. Our n is 3 in this case. Function, this function that is inside there, to the power of n minus 1, 3 minus 1 times the derivative of the function inside. So the derivative of this inner function, all right? So let's apply this formula. The derivative, if we follow this formula, it say n, if you check n is 3, yeah? So it should be 3, and then open a bracket, put your inner function to the power of n minus 1, so with 3 minus 1 to the power of 2, and multiplied by the derivative of the inner function. The derivative of the inner function is 2x. F of x is the function that is inside, so f of x is x squared plus 2. So, and another tip, always when you multiply by f prime, put it in brackets. For for simplicity, sometimes f prime will be having two terms. Okay, I'll show you next lecture. So this is just a derivative. Okay, it's simple. You don't have to multiply brackets out first, and then this formula just take you straight to the answer, and then you can just write the final answer simplified. 2 times 3 is 6, and then we have this x, and then x squared plus 2 to the power of 2. All right, this is the answer. Okay, you can pause this if you want to take a moment, but I will continue the rest of the examples. That was example 1, using the standard formula. And I will be only focused on this formula. This is the first formula on your formula sheet. It's also called the power rule. Why? Remember, when you have x, let's say f of x is x, you're going to have x to the power of n. So obvious, you're going to have n x if f of x is x to the power of n, and derivative of x is 1. You see, you get the power rule, x to the power of n, using this formula. If you let f of x equal to x. Yeah, I'll keep showing you those list of standard derivatives that I gave you, which you can get them from this formula sheet. I've already shown you the power function. If you let f of x, this one, equal to x, you have 1 to find the derivative of x to the power of n, which is a power rule. So it should be n, remember, x to the power of n minus 1, and derivative of x is 1. And so we get the power rule. Yeah, that's what I'm saying. What's those common derivatives that I gave you earlier, you're able to find them using a formula by letting f of x equal to x in those formula sheets, okay? And then you'll find that f prime in the formula sheet is 1. Example 2. We want to find dy dx if now y is equal to 2x squared plus 3x to the power of 100. Okay. What's I'm doing now? God. I want to derive this function y is 2x squared plus 3x to the power of 100. Okay. Dy dx, again, I see the form of this formula. I take my formula from the formula sheet. When I'm deriving a function that is to the power of n, the derivative should be in the form of n f of x to the power of n minus 1 times f prime. Okay, you can check from the formula sheet that I gave you. First standard derivative Here the derivative of this function, because y is a function to the power of n, so the derivative should be in the form of n. If we check, my n is a power function, power number, it's 100. And then a function which is 2x squared plus 3x to the power of 100 minus 1, so 99. Yeah? So times the derivative of the inner function. Yeah? Remember, when you multiply by the derivative of the inner function, you put it in brackets. So the derivative of what is inside is 4x plus 3. Yeah? Okay. So this is the derivative, okay, of this function. You see, we didn't have to open the bracket 100 times, so the formula make our life easier by just follow this chain rule, okay? And then again, let me tell you the importance of the bracket. Always when you multiply by a derivative f prime, this f prime here, you put bracket, because if engekho ama-brackets, if angekho ama-bracket, so this term looks like it's only multiplied to the first term, according to mathematics, if you know mathematics. By putting a bracket, I'm showing it, I'm multiplying. This is all function, include 3 is multiplying by this. So when I multiply it also, I mean I multiply 3 with this term. If I come up brackets, it looks like this 4x is only multiplied with this, which is the wrong value. All right. So brackets are very important. Okay. That's why I'm saying always put f prime in brackets. Okay. Now you understand this formula. That's just an extra of example. I'll give you 2 more examples, and then I'll continue with the next lecture. We want to find dy dx if y is equal to square root of 3x to the power 4 plus 2x. So always, if you have a square root like this, your function is the square root of a function. Just to give you a tip, if they say find the derivative solution, just remember that function you can write in the form of 3x to the power of 4 plus 2x to the power of half. So I want to find the derivative. As I can see, I have a function to the power of n, okay, which means I have this form of the standard derivative number 1. So this is the standard derivative when I'm deriving a function that is to the power of n. It should be n function to the power of n minus 1, and then multiplied by f prime of x. Okay, so this is the first standard derivative. If you can check from the formula sheet. Okay, so when you're deriving a function to the power of n, this is going to be n function to the n minus 1 multiplied by the derivative of the inner function. Okay, here I have y, which is function to the power of n. When I'm finding the derivative of this function, which is y is a function to the power of n, the derivative should be n down, n, and then return the inner function here, which is 3x to the power of 4 plus 2x to the power of n minus 1. Half minus 1 is minus half. And then times the derivative of what is inside. So the derivative of this, what is inside, always remember brackets. This will be 12 x to the power of 3 plus 2. Okay, this is your derivative. If you can like, you can write this in the denominator under the square root. This is the derivative of the function. So this in the numerator, because this is to the power of negative, we only have this thing, 12 x to the power of 3 plus 2 over, in the numerator we have 2, and this can go to the denominator because it have a negative exponent, but I can write it as a square root of 3x to the power of 4 plus 2x. Okay, yeah, and then we're done. And the last example for today, is this one. I want to find dy dx if my y is sine to the power of 3x. Okay, so here I only know the derivative of sine, not sine to the power of 3. Let's be real here. But here, as a solution, you see, I can write this as y equal to sine of x all to the power of 3. This means the same thing, right? You see, I have a function to the power of n. I want to find the derivative of the function that is to the power of n. I have the form of a function that is to the power of n. I know the derivative should be n, a function to the power of n minus 1, and multiplied by f prime according to the formula, right? Okay. A function when you derive a function to the power of n, it's n down, function to the power of n minus 1 times the derivative of what is inside. Okay, I always rewrite this formula so you can see it. So I'm deriving a function that is to the power of n. So it can, here if they're writing f of x, remember it can be any function. It's not always the algebraic. For simplicity, I always try the example with the algebraic functions. So as more you understand the rules of this formula, I can put now f of x as any function. You see, I'll put in terms of f of x as exponent function, as long if you see this form. Remember, apply the chain rule, this formula number one. This is the formula number one in your formula sheet. So the derivative of this, I'm applying this formula because I have a function to the power of n, which in f of x is a trig function. Yeah? So the function derivative is n, follow this formula, sine, we take n down, and then we return f of x, which is sine x to the power of n minus 1, which is 2, and then times the derivative of the inner function, which is cos x. Yeah. The reason why I was saying multiply, when you multiply by f prime, put brackets, is because when f prime, it have two terms, so it's very important to put brackets. But when it's one term, it's up to you. You can put brackets or not. It's up to you. So this is the answer. So this is just 3. It's sine to the squared x cos x. Okay, this is just the answer. All right. Okay, I know I said this is the last example, but I just see this nice last example I want to give you, but I will ask you to continue the simplification, because the simplification is just the high school work. Example, last example, we want to find dy dx if y is equal to x over 3 function. Let's make some mess. My function y is x over cube root of x squared plus 4. Okay, this is my function. So what you notice here, I see a quotient function of a function. I'm going to find a derivative using a quotient there. So, but before I derive, I know I can write this function as x. Always when you have a square root, you can write your function in terms of a power function. So the denominator I can write as x squared plus 4 to the power plus 4 to the power of 1 over 3. This is my function, okay? So I can write this function as x over x squared plus 4 to the power of 1 over 3, okay? So again, I'm seeing the quotient because I'm deriving a function over a function, okay? Let's apply the quotient rule. So dy over dx is equal to derivative of the numerator is 1 while we leave the denominator, right? This is the denominator. And minus and leave the numerator, which is x, and multiply by the derivative of the denominator. You see, when you derive the denominator, we have a function to the power of n in the denominator, which means you're going to apply the first derivative formula, that's number 1. You can take your number 1 if you're not familiar with the standard derivative number 1. When you're deriving a function to the power of n, let's follow the quotient rule there. Assume now we are using the quotient rule. Quotient rule say derive the numerator with 1 while we leave the denominator, and this is the denominator, minus, and now we leave the numerator and multiply by the derivative of the denominator. Now that's when let's find the derivative of the denominator, we apply the standard formula number 1, because we're deriving a function that is to the power of n. So that formula say we take n down. Our n is supposed to be 3, 1 over 3. From that n, we minus 1. So what is 1 over 3 minus 1? It's minus 2. Okay. And then multiply by the derivative of the inner function if you follow this formula. So the derivative of the inner function is 2x, okay. This is supposed to be 2. Y. This is supposed to be x squared, okay. And then you say all over denominator function (1 over 3 in squared), okay. So this is just a derivative. Let me repeat this. We apply the quotient rule because we see the function of a function. Always when you say a function of a function, you apply the quotient rule. Okay. So quotient rule, derivative of the numerator is 1 while we leave the denominator. Minus and leave the numerator and multiply by the derivative of the denominator. But when I was finding the derivative of the denominator, I see I'm deriving a function that is to the power of n. This is the first standard formula, number 1. I said Buagana and follow number 1. Standard formula number 1, when you're deriving a function to the power of n, is say you take n down, this is n, and then you return the function to the power of n minus 1. So our n, 1 over 3 minus 1 is minus 2 over 3. And then multiply by the derivative of the inner function. Always, the derivative is always multiplied by the derivative of the inner function. So the next step, which I think you understand, it's a high school work. It's just simplification, just for exercise and testing you if there was simplifier. Show that after you simplify this, you get x to the power of 2 plus 12 over 3 x squared plus 4 to the power of 4 over 3. Okay, this was my final answer. I hope it's correct, but please, this is correct. I have the solution, unless mine is a mistake here, but you can always consult if you might tell answer. All right. And thank you. And as next lecture, we're going to continue using the standard derivative formula sheets. Okay, so I wanted to focus on the first standard integrals, but as from tomorrow, as from next lecture, I'm going to mix all these standards that you see. I'll try to cover as many as possible. The only thing is for you to understand to use those standard formula. Okay, and yeah, thank you.